Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on October 27, 2025, about 3 days ago. This paper introduces a self-evolving, multi-agent reinforcement learning setup where a single large language model plays proposer, solver, and judge, and it reports an average improvement of 4.54% across multiple benchmarks without relying on human labels or special verifiers. The paper is titled Multi-Agent Evolve, LLM Self-Improve Through Coevolution. And as we will see, the closed-loop design and the judge-based rewards point to a scalable path for general reasoning gains. Alright, Figure 1 shows the closed propose-solve-judge loop powered by one large language model playing 3 roles. The proposer creates new questions, the solver attempts answers, and the judge scores both, which supplies domain general rewards. The solver gains reward for accurate reasoning, while the proposer earns a quality score plus a difficulty reward that rises when the solver fails. This adversarial yet cooperative setup keeps generating tougher, informative tasks and steadily improves reasoning ability. Well, Figure 2 presents the full pipeline, which keeps the 3 roles coordinated and stable. The upper panel shows the large language model acting as a general evaluator, so the agents interact directly and self-improve across coding, reasoning, math, and knowledge. The lower left panel adds quality filtering, which routes weakly formed or trivial questions to a dump while retaining good ones to seed training. The lower right panel applies Task Relative Reinforce++, a reinforcement learning scheme that normalizes advantages per role to cut variance. Synchronized updates then push one shared model forward. Alright, Table 1 reports accuracy across many benchmarks and contrasts seed settings. The top section shows that MAE0, which uses no reference questions, improves over the base and AZR on most tasks, with big jumps like math near 68 and squad around 92. The lower section adds reference questions, and the half-reference variant delivers the best overall average, about 60, while keeping gains on both in distribution and held-out sets. Color bands mark those two groups. So Table 1 contrasted seed strategies and reported the best overall average from the half-reference setup. Figure 3 shows how the training dynamics support that result. The left panel tracks a steady rise in valid questions because quality filtering removes weak items while the dataset grows. The middle panel plots difficulty, which climbs toward a challenging yet solvable range. The right panel reports overall accuracy improving across steps, suggesting that calibrated difficulty translates into tangible performance gains. So while the previous figure showed training dynamics improving steadily, Table 2 tests which parts actually matter. The ablation table reports that the half-reference setup leads with an overall average near 60, while dropping any agent role reduces scores across tasks. The blue block shows that removing proposer, solver, or judge hurts stability and accuracy. The green block highlights safeguards, where turning off question quality filtering harms results more than removing the format reward. Wrapping up, 2 takeaways stand out. The 3-role co-evolution with judge-based rewards reliably boosts reasoning, and safeguards like quality filtering and calibrated difficulty make training stable and data efficient. The broader implication is scalable self-improvement without human labels or special verifiers. That is it for this episode of the AI Research Roundup. I am Alex, thanks for listening.